Good morning. So we are here at our last week of school. I know when we left in March, we did not think this is the way we would finish out the school year, and unfortunately, it is. So I'm very proud of how you all have done and persevered through all of this in these tough times. So this week we're going to finish up a little bit with rational expressions and go over dividing. And then Wednesday, we'll just review what we've done with rational expressions and be finished up for the year. All right, so let's talk about dividing. We know rational expressions are fractions, so let's talk about if we divide fractions. So let's say we have, divide there. So let's say we have 1/2 divided by 3/4. Let's think back to elementary school, to 7th grade, Miss McNamee's class. I know that you learn kind of a way to say and remember it. When we divide fractions, we're not actually dividing fractions. We keep the first fraction, we switch this to multiplication, and then we flip the second fraction. So sometimes we think about it as like keep, switch, flip. So I would do 1/2 times 4/3. Two ways I could do this. I could go ahead and multiply straight across and get 4/6 and then simplify that to 2/3. Or I could say, okay, I could cancel that to a 2 and then go straight across and get 2/3. This is kind of the idea we're going to keep here. But we still, when we're dividing fractions, because rational expressions are fractions, we'll have to use this idea. So let's talk about our steps. Notice the first step in every one of these that we've done so far has said factor, and that's what we'll be doing again. You're going to factor all your expressions. You're going to find your domain exclusions. The timing of this is going to be very important on when you find your domain exclusions. Then you're going to do your process for dividing, so keep, switch, flip. Then we're going to find domain exclusions again, because we now, since we flipped a fraction, have a new denominator. So we have to do that twice. Okay. Then we'll do our simplifying. All right, so let's look at some examples on what this means. All right, so first thing we're going to do is we're going to factor all our expressions. So here, reverse FOIL. So multiplies to -8 and adds to -2 is going to be -4 and 2. X squared minus 9 is a difference of squares. And these won't factor. All right, so I go ahead and find my domain exclusion. So -3 and +3. That's -3 again. So I'm going to go over here to the side out of the way and put the x cannot be plus or minus 3. You must put this. Okay, so if you leave this off, you're leaving off half of what I'm looking for. So you must always put the domain exclusions. Okay, then we're going to do step 3, keep, switch, flip. So you keep the first fraction. So this stays the same. I know some of you are going to want to kind of put steps together, and I'm okay with that as long as you come out with the right thing in the end. Okay, then we switch division to multiplication and then flip the second fraction. We now have a new fraction. That means we have a new denominator. So what will make this denominator 0 is 4. So that also has to be a domain exclusion. Then we just simplify. So I can simplify the x plus 3, the x minus 4, and then I'm left with x plus 2 over x minus 3. And x cannot be plus or minus 3 or 4. And remember, we find domain exclusions before we simplify anything. Some of y'all were not doing that correctly last week. So we got another example. Alright, so we're going to factor all of our expressions. So this one, reverse FOIL, is going to factor into x minus 1 and x minus 1. Here I have a GCF of x. Here, the reverse FOIL, that's going to be x plus 2 and x minus 1. Here I have a GCF of 3. Alright, so my domain exclusions, what will make x equal to 0? Well, 0, so x can't equal 0. Now, x squared plus 1, what will make that equal to 0? So let's go over here to the side and try to see what makes that equal to 0. So if I subtract 1, I get x squared equals negative 1. Take the square root. I'm taking the square root of negative 1. That's imaginary, so that's not a real number as an answer. So there's nothing that will make this equal to 0. So I don't have another domain exclusion there. So now I do my keep, switch, flip. So I keep the first fraction. Switch to multiply, flip the second one. I now have a new denominator. So what will make these equal to 0? Negative 2 and 1. Now I simplify. I can simplify the x squared plus 1 and the x minus 1. So here in the numerator I have a 3 and an x minus 1. In the denominator I have an x and an x plus 2. And so this right here would be my answer. Alright, one more example. Try to get another sheet of paper. Alright, so again, factor all expressions. So here we have reverse FOIL. That's going to factor into x minus 5 and x plus 3. Here we have a GCF of 4. Get to x plus 5. That's just 2. And then here we have a GCF of 2. That's going to give me 2x plus 5. Alright, then domain exclusions, 4 won't ever equal 0, 2x plus 5, what will make that 0? Solve that and we get negative 5 halves. 2 will never equal 0, and again we have negative 5 halves. Alright, so we keep, switch, flip, so I keep the first fraction. Switch to multiply, flip the second one. And then we see things that will simplify. So these 2's will simplify, and this 2x plus 5 will simplify. So I'm left with x minus 5, x plus 3 over 4. Oh, and when I flipped my second fraction, I didn't get a new exclusion because 2 will never equal 0. So this would be my final answer here. Alright, so today we're going to practice some of this, and then Wednesday we'll review and do an assignment over all of that with rational expressions. Message me any questions. Have a good day.